Hi, this is Tom, and welcome to Lesson 29. In the second part, let's return to our poker hand for a moment. And we're gonna kind of flash in and out of this example, because actually counting poker hands can get pretty difficult, but there's a lot of interesting concepts inside of it. So here we go, poker hands. Suppose, and I'm gonna be really careful about this. For example, if I want a seven of clubs, I would write 7 with a little C next to it. If I wanted an ace, I'd write A, and if I wanted an ace of spades, I'd put an S by it. If I had a 7 of hearts, I'd write 7 with a little H by it. If I had, maybe I have a 10, and let's make that one, oh, we don't have a diamond yet, so we'll put a diamond there. And, oh, let's put a 7. Let's give it another 7, and this one will be a diamond as well. So I have clubs, spades, hearts, diamonds. I have all 4 suits. Now, if this is the hand you're dealt, you may look at it and be thinking, well, that's okay. But we'll call this hand 1. But you can pick the cards up and you can rearrange them. And let's rearrange them on purpose. Let's notice there are these 7s. 7 of clubs. I have a 7 of hearts. I have a 7 of diamonds. I have a 10 of diamonds and an ace of spades. Well, when I rearrange those, we'll call this hand 2. Now it's very easy to see that I have a 3 of a kind, which is a pretty good hand. So the idea here is that the order of the cards that were dealt does not matter, and we're going to continue on this idea. So let's try this. Consider the letters. Consider A, B, C, and D. And here's what we're going to do. And we're going to do this painstakingly, because what we're going to do is we're going to write all possible 3-letter words. Okay, so here we go. Get your patience and your thinking cap, and I think we can get through this. So I'm going to just start with A. So let's see, say I write A. Now I could write I could have A, B, C. I could have A, B, D. I could also have a, let's see, I could do C, D. I could do I could switch some of these orders again too. I could do A, D, C, and I could have A, D, B, and finally, I think the one I forgot was A, C, B. Yeah. All right, now let's try it again. Now let's start with the letter B. So if I start with B's, I could do B, A, C, and then I could switch those. Oops. I could do B, C, A, and then I could come down, see B, I could go A, D, bad. Or I could do B, D, A, or, oh, we need B, C, D, and finally B, D, C. And let's see, now let's start with the letter C. I could do C, A, B, or C, B, A. And then let's see, I could do C, A, D, C, D, A, C, B, D, and C, D, B. And finally, let's start with D's. How many ones with D's? Well, I have D, A, B. I can switch those for a D, B, A. I have D, A, C, D, C, A. D, oh, here we go. Yeah, D, B, C. And finally, D, C, B. Now, if I count all those up, notice that there's 24 words. 24 words. have. And we actually could have found that fairly easy by using what we've learned. We could have said, well, there's 4 different possibilities in the first position, 3 in the second, 2 in the third. So that if I multiplied those together, I'd say 4 times 3, that's 12, times 2, that's 24. And that's what we would expect. Now, we're going to add something. Suppose the order of the letters. Suppose order of letters does not matter. How many words? Well, let's see. So I'm going to start doing this in colors. Let's try some orange. So for example, here's A, B, C. So what I need to do then is if I have any other words that have an A, a B, that are made of A, B, and C, even in a different order, that's just a repeat, and it's not a new word. So for example, here's an A, B, C right next to it, and here's another A, B, C, and oh, here's an A, B, C, A, B, C, and there's probably another one in here. I just have yet to see it. Right there at the bottom corner. Okay, good. Now let's try another color. Let's try red. So here's another word, ABDs. So now what we want to do is anything with an ABD, we need to put a line through as well. So here's one right below it, ABD. Here's an ABD, ABD, and we want to keep going through with this process. ABD. Oh, here's an A, B, D, A, B, D, and I think I got them. All right, now let's try another. We'll use green. How about A, C, D? Let's find all of our words A, C, D. Oh, there's one right beneath it I could strike. A, C, D. Oh, here's an A, C, D, A, C, D, A, C, D, and there we go. And we have one more color. I like this bright magenta color. Oh, here's a B, C, D. So now I need to strike the rest of my BCD. So there's a BCD. Oh, there's one. There, and there. Now wait a minute. After we've taken our permutations. That's what this first set was. These were permutations that we started with. But when we said the order doesn't matter, what we found in these 4 boxes is we've found the combinations. And so how many words? We'd say there's 4 words. There's 4 different words. And those were the ABC. That was the orange one. In red, we had the ABD. In green, we have ACD. And in the magenta or purple, we have B, C, D. So the question is, well, how could we have figured that out without having to do all that writing? Because just one more letter would have made this very difficult. Well, here's what we could do. If we start out with this piece right here, we'd say, well, if all of those were different, there was 24 words. And that came from 4 times 3 times 2. And then, but wait a minute, that's the permutation if I go times 1, so I'd also have to divide it by a 1. Okay, now that might seem a little strange, but bear with me here in a moment. Then this was the permutation of 4 permuted 3 ways. But here, and let me write that better. That's not very good. There And the permutation came from 4 minus 3 because we wanted it to stop with the 1. But here's what happened now. Now we said, well, we're just all the groups of 3, those are just repeats. So if you have a group of 3, that can make 3 factorial copies of itself, but we just want 1. So what we needed to do to get our final answer is we needed to take our permutation and divide it by the repeats. The repeats, since order does not matter. So, in other words, what we've done is this. We've taken the problem is this. So the total number of words we said was, well, it's 4 permute 3. And then we divided that by 3 factorial. So I'm going to do a little bit of math for you. This is 4 permute 3 is 4 factorial over 4 minus 1 factorial. And then if we're going to divide it by 3 factorial, that's 1 over 3 factorial. Well, this just becomes 4 factorial over 4 minus 1. Oops, I'm sorry, not 1. This should be a 3. Oh, goodness. 4 minus 3. 3 factorial. And we call this 4 choose 3. This is read 4 choose groups of size 3. And if you work through that, it does in fact give us exactly what we want. That's 4 factorial. That's 4 times 3 times 2 times 1. 4 minus 3 factorial is 1 factorial, which is just 1 times 3 times 2 times 1. Look at that. All this cancels, and our answer is 4. And in general, we say n choose r is equal to n factorial divided by n minus r factorial r factorial. All right, let's try one more example here. I think we have time for that. How about this? 10 people meet to play basketball. Now we're going to make this very clear. We're going to call it pickup basketball. Doesn't have quite the structure. So the order of your position doesn't matter. Now some probably would argue it does, but for this example we won't let it. So in other words, if I want to figure out how many different teams well, what I would do is I would say, all right, that's going to be 10 choose 5. So in other words, there's 10 total, and I want to choose all possible groups of 5. Well, that's 10 factorial divided by 10 minus 5 factorial 5 factorial. And if we work that out, you end up with, well, we could do this. That's not so bad. So 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 5. 10 minus 5, that's 5. So 5 factorial is 5 times 4 times 3 times 2 times 1 times another 5 factorial. So notice then that there's a 5 factorial there and there. Those cancel. And I have a 3 times 2, that's a 6. And then a 5 times 4, well, let's see. That 5 times 4 is 20. So I'm going to cancel the 10 and a 2 from the 8. So my final answer is 9 times 4 times 7, which is 252. All right, then, so there's one last thing, and that was, remember when we looked at our group of sevens? So how many ways to draw 3 sevens from 4? Well, that's exactly the same problem as A, B, C, D that we did up here, because the A might be 7 of hearts, the B could be the 7 of clubs, the C could be the 7 of diamonds, and the D could be the 7 of spades. Hopefully I said those correctly, but all you wanted is any group of 3 of those, and the order of the sevens doesn't matter. And so the answer to that is exactly the same as how many words from A, B, C, D if order doesn't matter. Thanks for watching.